we're looking at volume of cones and pyramids. How much will fit inside that ice cream cone of yours or inside a pyramid? I guess we don't have ice cream in pyramids usually. One of the fascinating things is, and you might want to look up another video on YouTube and see, if you fill this up with a liquid and dump it into a cylinder of the same height with the same congruent base, it will actually take 3 of these to fill up this one. It's a third as much space inside. And it turns out it works that way for both cones and for pyramids. And so how many cones would it take to fill up the cylinder? 3 cones. Has the same volume as 1 cylinder. And again, same thing works for our rectangular prism and our pyramids. It takes 3 pyramids to equal 1 of the prism. And that's when it has the same exact height and the same exact size base. Okay. So here's the formula for you. It's pi times radius squared times height. So we're finding the area of the base times the height, just like we would with a regular prism or a regular cylinder. And then we're cutting that answer by a third because it's only holding 3 times, or 3, it only holds a third of what the regular one would. Often the formula is written as 1/3 pi times radius squared times height. But I often find students have a better time with just solving up here and then dividing by 3. All right, so looking at our cone over here, how much ice cream would fit if we didn't put a scoop on top, just filled it up inside. And again, I like to start with the radius and the diameter and the height. Just write them down so you have them ready to go. 2 was all the way across. Diameter, radius then has to be 1, and my height over here is 6. And then I'm going to use my formula and substitute the numbers in that I know. So for pi, I'm going to write 3.14. For radius, that's 1. And then I'm going to square it, which is still 1. And then for my height, I have 6. And then I divide all of that by 3. I'm going to take a shortcut and cheat here. 1 squared is just 1, so I'm going to erase the squared now because I've already solved it. And then another great thing is that look to see if anything in the numerator can be divided by the denominator. And if so, you save yourself some trouble with work. 6 divided by 3 is 2. So I'm left with 3.14 times 1 times 2. And so that right there is a lot easier to do. In this case, we're going to get 6.28. And we had inches. And it's volume, so we're going to put to the 3rd power. 6.28 inches cubed. And there it is. That is the volume of the cone. Same thing with pyramids. So we have volume of a pyramid. And for this one, just pay attention, it's down here, that the base can be all kinds of different shapes. The base could be a rectangle, and then the area of a rectangle is base times height. The base could be a triangle, so you have to use base times height divided by 2, or some other shape as well. So pay attention to the shape of the base, because again, you're doing area of the base times the height of the whole shape divided by 3. So this case, we're going to look here. I know that my base is a rectangle, and so to find the area of this base, it's going to be 4 times 7. Ooh, 4 times 10. So that's the area of my base, times the height of the whole thing is 6, and all of that would be divided by 3. Shortcut again, hey, 6 divided by 3 is 2. So now I'm left with 4 times 10 times 2. 4 times 10, 40, times 2, 80. And my units were in centimeters, and we're talking volume, so it's how many cubes fit inside? 80 centimeters cubed. So this is area of a pyramid or cone. It's always a third the size of its counterpart prism. And one thing you want to pay attention to is the shape of the base. And once you do that, you've got it down. All right, guys, later.